Okay, so we're going to go over aerobic cellular respiration, and the first thing we're going to do is check out the textbook formula for it. So to start off, we're going to show our reactants. So we have glucose and oxygen. Oxygen would be why it's called aerobic. If you take the oxygen out, it's anaerobic. But we want aerobic, so we're going to leave the oxygen in. And what we get from this is water and carbon dioxide, so it looks an awful lot like a combustion reaction. We also get some energy. Now, why is energy in the shape of a star? Well, because that's how we think of it sometimes, isn't it? We think of suddenly there being a flash of energy. So we're not going to think of it like that anymore. What we want to do is come up with a new formula that's a little bit better. So instead of energy, we're going to think of this, ATP. Now, ATP is short for adenosine triphosphate. And what this reaction actually does is produce ATP from its reactants. ADP, adenosine diphosphate, and pi, or just one phosphate group. So this is what we're hoping to accomplish. ADP plus a phosphate group going to form adenosine triphosphate. So why ATP? Is ATP the same thing as energy? In a lot of textbook examples, you'll see people use the two terms interchangeably. They'll say that cellular respiration produces energy, or they'll say that cellular respiration produces ATP. Well, these aren't the same. ATP is a molecule, as you can see by this picture. Energy has another definition. Energy is defined as the ability to do work. So why then do people keep using them as though they were the same thing? Well, the cell can take ATP and it can break this last bond to release the energy. Many cellular functions require this. Glucose is also a high energy molecule, but the cell can't use it the same as ATP. That's why cellular respiration exists in the first place. So a better definition for aerobic cellular respiration is not that it produces energy for the cell, but rather that it produces ATP, which is a high energy molecule that the cell can use when it needs to. So let's take our new knowledge and see if we can apply it to our original formula for aerobic cellular respiration. We'll start with the reactants, glucose and oxygen. But we're going to add ADP and a phosphate group. For the products, we're still going to have carbon dioxide and water being formed, but we're also going to include the most important product of aerobic cellular respiration, ATP, energy that the cell can use. In an ideal world, we'd be finished. However, nothing is perfect. Some energy is going to be lost in the form of heat, so we'll add it to our products. You may notice that simple energy, depicted by the star, has been taken out of the equation completely and replaced with ATP. So there you have a more comprehensive formula for aerobic cellular respiration, but even this is still very oversimplified. In the remainder of this section, you'll explore the major steps of this process in much more detail, and you'll see for yourself. Good luck.